Let's look at graphing y equals the absolute value of 3x minus 6. You want to make sure you're using a pencil for this one because you're going to graph and we're going to erase the parts of the graph we don't need. So you might want to pause and grab a pencil if you need to do that. Okay, so once you've got your pencil, let's look at graphing this. So I've got a pencil here for this part as well. So y equals 3x minus 6. I'm first going to graph y equals 3x minus 6 without the absolute value brackets. And again, the strategy I like to use for graphing linear functions that I find is the most efficient is using y equals mx plus b method. So that means I have a y-intercept of -6. I'm going to plot that point down there on -6. My slope is 3, which means I have a rise over of 3. And my run is 1, if you need to visualize that as a fraction. So it's rise over run. So from my y-intercept, I'm going to count up 3, 1, 2, 3, and then 1. Now I can just grab a ruler and eyeball it from there, but I'm not always the best at drawing my lines perfectly straight. So I like to have a few more points. So I keep counting with my slope. So from this point, I'm going to count up 1, 2, 3, right 1, 1, 2, 3, right 1, 1, 2, 3, right 1, 1, 2, 3, right 1. So this allows me to extend it. I definitely need part of the graph above the x-axis, so you need a long enough graph. If you needed to extend it to the left, you're just going to count down 3 and left 1 to see that pattern. So again, make sure this part's in pencil. This is not my final answer. Here, you would put arrowheads here along there. So I just drew that long enough so you can kind of see it more clearly. Now we're going to apply the absolute value. So to apply the absolute value, the part above the graph stays the same. So I'm going to just redraw that in pen for you to see that this doesn't change. That stays the same. But everything below the x-axis, meaning the negative y values, flip. So instead of it being a -3y value, it's now a +3. So I flip that up to +3. I take -6 of my y-intercept and I say I now have a +6 y-intercept. -9 becomes +9. So you're going to get the V shape. If you ever start with a straight line, we call that a linear function, your absolute value graph will always be a V shape. Now I can erase this. You don't have to erase it so hard that you can't see anything, because it's a good idea to maybe see what your work was, or you can always label both parts. To help you, if you don't want to erase it, you would have to label both, but usually we just erase so we can clearly see our V shape. Okay, let's look at the piecewise function. So piecewise function is this general rule here. So you're always going to say y equal and open up that one bracket. So you start with what your original graph was. So what was the first thing we graphed was 3x minus 6. We look at 3x minus 6, which was this graph on the right-hand side of the V. But I erased everything below the x-axis. So it's 3x minus 6, but only to the right of the V. So to describe that, we're going to use the domain. It's when x is greater than or equal to 2. So that happens when x is greater than or equal to 2. So the right-hand side. Then what happened with the left-hand side, we've changed our y-intercept is now positive and our slope is now negative. So these two numbers changed. And what you're really going to do, I'll just do this over here on the side to show you where this equation comes, is you're going to bring a negative sign through your 3x minus 6 equation. So that's going to become -3x plus 6. So you don't need to show that work. You can just change both signs. That's really what this graph was. It has a y-intercept of +6, down 3, right 1, negative slope. So what part was graphed, or what part of the domain is for that graph? It's everything less than 2. You can't include 2 again. It's always going to be you can consider your x-intercept as the point that didn't change from your original graph. Let's just review domain and range for this graph now. The domain is still x equals, the arrows continue in both directions. You can also use -infinity to +infinity if you prefer interval notation. For the range, it's everything above the x-axis, so y, such that y is greater than or equal to 0, where y is the element of real numbers, or you can say 0 with square brackets to infinity. Any intercepts we have, the x-intercept is 2. You can visualize that. If you weren't sure, the x-intercept never changes with the absolute value bracket, so you can always actually find it algebraically if you need. So to find the x-intercept, you'd let y equal 0. And you can see how we're still going to get 2, but that's how you would do the question if you didn't have the graph. And then the y-intercept, we can see in our question how it was 6, but I want to make sure I show you algebraically. Sometimes the y-intercept is so far off the page you can't see it on the graph, or you'll have to do it algebraically. When determining a y-intercept, you must use the original question with the absolute value brackets in there. So when you're plugging in your x values, you get -6 of absolute value, which is +6. So had the absolute value brackets not been there, or it was graphing y equals 3x minus 6, my y-intercept is -6. So when you're asked to show work on the y-intercept or calculate that, make sure that you show this calculation and show that you're using your absolute value brackets, or you will have the wrong value for positive versus negative.